Hello, in this video I'll be talking about one of the most common data structures, arrays, and compare it to another data structure, linked lists. Today I'll be talking about one-dimensional arrays as they are one of the most popular data structures and how simple it is to use and understand them. They are a set of spaces in memory, each containing a value with an index tuple. These indexes are contiguous and most often start at 0 followed by 1, 2, and so on. To make them easier to understand, we can imagine them as seats on an airplane. People start arriving and they take their seats from the first until the last one. The great thing with arrays is that we can retrieve any value if we know its index. Therefore, I can go to seat 5F and we see who is sitting there. Or we could search for a specific person, one by one, as the passengers are more likely not ordered in any particular way. Once we find who we are looking for, we can return their seat, or index. The array, in this case the plane, is good for finding people as they all have an ordered seat number, or index, that doesn't occupy extra space. It also has its limitations as we have a fixed amount of seats for the airplane independent of how many people are flying, which means we might have empty spaces or not have enough spaces, which will mean getting a bigger airplane and moving people over to the bigger one. So to summarize, arrays are great for finding items, especially if they are sorted. If we use a divide and conquer algorithm, such as binary search, which has a logarithmic complexity. If the items are not ordered, we may need to scan for each item, making it as bad as linear complexity. They don't use extra spaces for storing pointers. Adding and removing items take linear time, if they are added or removed at the end, as long as there's still space available, and as bad as linear complexity, to add or remove from inside the array, as we will need to shift the index of all the items right of the inserted or deleted one. One of its biggest downsides is its fixed size, as we may have wasted space if not full, or need to copy every item to a bigger array if we run out of space. Thanks to all of this, we can use arrays to store text. For example, any string of text is just an array of characters. Arrays bring us to a similar data structure, linked lists. Linked lists are a collection of items in which each element points to the next. Therefore, each element consists of two parts, the value itself and a pointer that shows where the next element is located in memory. There's one special element that has a third part, the head, which indicates that it's the first item in the list. For today, I'll be explaining only single linked lists, but bear in mind there are also doubly and circular linked lists. Imagine a linked list like a treasure hunt. At the beginning, you get the first item with a clue to the next one attached to it. The items could be anywhere, so I need the previous item to find the next one. Adding and deleting items is fast, with a constant complexity. To add an item in the head, you just need to store the previous head, make the new item the new head, and set its pointer to the previous head. Deleting the head just means that we need to select the second item in the list and give it the head value, and delete the previous head. To add an item in the middle, you need to store the two items that the new one will be sitting in between, set the pointer to the previous item to the new item with a pointer to the following item. Deleting an item in the middle means taking the pointer of the item before the one we want to delete, set its pointer to the one that follows the one to delete, and then remove the item. It's important that we don't get detached items, so we need to make sure that when modifying a list, we can always set pointers correctly. To summarize, lists are great for adding and removing items as they take constant complexity, whereas searching inside a linked list can be bad as linear time complexity, as we need to search item per item. And while the size is only as big as the list is, we need extra space to store the pointers. Furthermore, singly linked lists are difficult to traverse backwards, but doubly linked lists, which allow for this action, take even extra space for back pointers. A good place to implement linked lists are album track list, browser history, image viewers, or anything that we can go back and forth, using doubly linked lists, as it's very quick to retrieve adjacent items.